Right, so this week is about stack. So let us take a look at what is a stack. Okay, by definition, okay, stack consists of homogeneous elements, okay, elements of the same type. Okay, and when we are talking about the operation that can be performed on stack, okay, so just like the previous data structures that you have learned, right, array list, linked list, and also queue, okay, so main operations are deletion and addition, yeah, deletion and addition. But compared to queue, stack is even simpler, yeah, because addition and deletion of elements occurs only at one end, yeah, only at one end, and that end is called the top, yeah, the top of the stack, right? And this data structure is using the concept of last in, first out. Okay, last in, first out. Yeah. This is opposite of a queue, where queue is actually first in, first out. Yeah. So stack is using last in, first out. Okay. And these are various types of stacks. Okay, so from this diagram you can see a stack of coins, okay, stack of trays, yeah, stack of boxes, okay, and stack of books. Okay, the way you arrange these elements or things, yeah, it's just like stacking, yeah, stacking the things, right? Okay, now, so what is last in first out data structure? Yeah, so last in first out means, okay, the last, yeah, the last element added, yeah, to the stack will be removed first. Yeah, the last element added will be removed first. Okay, and top element of stack, yeah, is the last element to be added to the stack. Okay, elements added and removed from one end, yeah, from one end. So if you refer to the previous diagram here, right? So if you view the previous diagram here, so you can see, for example, like stack of books, yeah, stack of books. So if you want to add more books, yeah, you want to add more books, then you will add it on top, yeah, on top of the stacks. Okay, so you want to insert. So let me just draw it. Hold on. So if you want to insert, yeah, you want to insert, okay, insert. So let's say I have one book to be inserted, right? So that book will be inserted on top, yeah, here, right, on top here. So you have another book inserted here, okay, on top. Okay, and you want to remove, yeah, this is insert, you want to remove, you want to remove, then you also remove the top elements, yeah. So insertion and deletion only occurs at one end, yeah, which is the top of the stack. All right, so actually it's easy in terms of the concept, right? So you just imagine you have stack of something, a stack of something. Okay, you want to insert, you will insert on top of it. You want to remove, then you remove the top elements, on the stack. All right. Okay. Now, as I said earlier, so stack operation is even simpler, as compared to queue. So in queue, you have two ends, okay, two ends to perform insertion, insertion and deletion, right? But for stack, okay, insertion and deletion from one end, okay. So here we have examples of empty stack, yeah, on the right hand side, yeah, empty stack. Okay, and we have five elements, yeah, five elements, yeah, figure 6.2. Right, and then next, okay, look at the operation performed, yeah, on the assuming this stack consists of books. So from the empty stack, yeah, so insertion, yeah, in stack, yeah, insert is push. Okay, we call it push. And later when you implement the user define my stack, then you will write the method name push. Okay, whereas delete or remove, this is pop. Pop, push and pop. Okay, so first operation, A, okay, push box A. Book or box, in this case is a box, push box A. So now your stack has one item, which is A. And then next operation, you push box B. So now B is push on top of A. Okay, next push box C. Okay, so C is on top of B, right? And if you perform retrieving the top elements, you retrieve, okay, retrieve, we call it as top, top. Okay, this one is actually not removing, it's only retrieving, retrieving the top elements, retrieving the top elements. So when you retrieve, you will see the item C. Okay, you cannot see B, you cannot see A, because it is at the bottom. Okay, so you only see the one on top. So next, you push another box, which is D. So D will be pushed on C. And then when you pop, you pop the stack, so D will be pop out. So now you only have 3 items, A, B, C. Okay, because D has been popped out. Pop out. Alright, so far so good, class?
Good.
Alright, okay. Alright, okay.
Great.
Okay, thank you for the feedback. Okay, next. Okay, let us focus on the basic operation here on stack. So this one is just like the previous data structures that you have learned. Okay, so these are the basic methods that we need to know. Okay, first one is empty. Okay, this is to check whether the stack is empty. Yeah, if it is empty, it returns true. Yeah, otherwise it returns false. Okay. And then is full, check whether the stack is full. Yeah, if it is full, returns true, otherwise returns false. Okay, and this one normally you can check whether the stack is full if you implement it using array, using array list, right? Because you have like a fixed size and so on. But if it is dynamic, it depends on your memory. If memory full, then of course you cannot perform the operation. Right, next top, next is top, returns the top element of the stack. Okay, in queue we have get first, okay, and then get last. Okay, but stack is even simpler, so we retrieve only the top elements. Top, the method name is top. Okay, and of course before you can retrieve, you need to check whether your stack exists and must not be empty, right? Okay, next pop. Pop is this one is to remove or delete. Okay, by the name pop. You know, like popcorn, right? Do you know how popcorn is made? Why is it called popcorn? Why is it called popcorn?
It will pop.
The popping.
Because it pop.
It pops out. Okay, maybe those who have seen how the popcorn is made, you can see that the things will be pop, pop out. Okay, so this is the I would say the most appropriate method name, for pop, popping out. Okay, so this one remove the top element of the stack, and of course before you can remove, you need to check whether stack exists and whether the stack is empty or not empty. Okay, and then push, insert. Okay, when you push something means you insert something. Okay, so this one will be added at the top also, top of the stack. Pop also top, top element of the stack. Okay, the input consists of the stack and the new elements. Of course, before you can insert something, you have to create the new elements. Okay, and again, okay, you are going to implement my stack using linked list, Okay, we will just focus on linked list, right? Okay, and of course, again, you need to do some error checking. Error checking. The stack must exist and must not be full, so that you have empty slot to insert the item onto the stack. Okay, now I give you some I would say class implementation, okay, but not a complete one. Okay, so you are going to complete the implementation of stack using linked list during lab session this week, right? So we have less reference variable, right? So for my stack, we just need two link or reference variables. The first one is called stack top, or maybe you can just name it as top, right? And the second one is new node. Yeah, new node is a reference variable that you will use whenever you want to create a new node and traverse the stack, right? Okay, so for default constructor, you just initialize stack top to null, yeah, because you're going to implement using a linked list, so just initialize stack top to null. Okay, now let me briefly explain the process of inserting and also deleting item from the stack. Concept is using a linked list, using a linked list. So previously you have done linked list, okay, you have implemented my queue, okay. I hope you have better understanding on the linked list, on the linked list concept and also the operation. So for stack, also you will implement using linked list. Okay, so this is how the node is drawn. Okay, you can see that for empty linked list, so stack top is pointing to null. Okay, so this is the diagram to show that the stack is empty. On the right hand side, okay, on the right hand side, we have a stack that consists of 3 elements. Okay, 3 elements. Okay, by looking at this figure, okay, which one is the top element? Which one is the top element?
C.
Yes, thank you very much. C. Yes, C. How do you know that C is the top element?
Last in.
Betul.
Okay, last in. Last in. Okay, last in. And how do you know that this is the one which is added last and not A?
Last in, first out.
Yes, betul. Last in, first out. Okay. Look at the stack top. Where stack top is pointing to?
C.
C. Okay, stack top is pointing to C. So meaning that this is the top elements. Okay. Well, maybe some people might draw it differently. Okay, might draw it differently. This one is like vertical position because you can imagine this is stack of elements. But maybe some people will draw it something like this. Okay, just like a linked list. Okay, but how do you know that which one is top and which one is the last one? You look at the top. Yeah, if top is pointing here, so meaning this one is the top element. Yeah, top element. So top is just like head, and also first, in queue. Yeah, head in a linked list and queue is first. Right? But this one is the common drawing for stack, because you can imagine you are stacking up the items. All right, okay. Next, okay, so this is the default constructor. Okay, stack top equal to null. Okay, now we are into implementing push and pop. Yeah, push and pop. Okay, so today I'll just show you the steps. Okay, and during lab session this week, you're going to write a full method for push and pop and some other methods, and then test your my stack class. Right? Okay, now push. Yeah, push. Stack before the push operation. Okay, look at this diagram carefully. Right? So we have 3 items. Okay, the one on top is C. Okay, now I create a new node D. Okay, here I have a new node. Okay, and then this is D. I want to push it onto the stack. Okay, so what should I do in order for me to insert this to the stack? using the linked list concept. Exactly, using the same linked list concept. So what should I do? Maybe you can say it in terms of code if you are if you if you are comfortable already, yeah. Or maybe you can just draw, yeah, which pointer should point where, and then transform it into code. Okay, so what is your first step? What is your first step? Now the stack top is pointing to C. I have new node pointing to D. I want to push D onto the stack. Anybody? Same concept with linked list.
New node dot next equals to stack top.
Okay, new node dot next. So this is new node. So new node dot next is here, right, Akmal?
Yes.
Yes. Okay, so you want it to point to, oops, sorry. You want it to point to new node dot next, right?
Point to stack top.
Point it to stack top. Okay. So make new node dot next. So this is new node dot next. Okay, so new node, I'll transform it into code. Okay, new node, this is new node, this is new node dot next equal to stack top. Okay, all right, good. Any more step?
Stack top equals to new node.
Okay, now since this one is the top, this D become the tops of the stack, so you need to remove stack top to be pointing to new node. So next step will be stack top equal to new node. Okay, good. Right, exactly the same. It's only that I use a different variable, yeah, for stack, right? But drawing is also a bit different, but actually doesn't matter, as long as you understand, you can draw in any way you want, yeah, as long as you understand the step and you can write the codes. Okay, right? So this is the answer on the next slide. Okay, so we have new node. So in this example, the author use link, yeah, but in our codes we use next, data and next, yeah. Here the author use link and info. So we have new node dot link, new node dot link equal to stack top, yeah, new node dot link equal to stack top. So this is the first step, and second step we do. So this is first step, second step we do stack top equal to new node. So that's the drawing of it. Eh? So far so good. Any question?
Good.
Good.
All right, good. Yeah, it should be easy. Okay, because as you have already implemented my linked list, you have already implemented my queue, so stack should be easy, right? Okay, next. Okay, for top elements, top element. So we just retrieve the top element. So this is the top element. Okay, so this is top element D. So you want to retrieve top D. So this one is stack top dot. So now this is stack top. So we have stack top dot info. Okay, or data. Yeah, since the author use info and link. Yeah, info and link. So to return the top element is stack top dot info. Okay, so it's good to do some error checking here. So if stack top equal to null means your stack is empty, then you can display error message. Okay, but this one is using the error exception handler, from the Java compiler. Yeah, you can use this. This one is a specific exception for stack, stack underflow exception, or you can do as simple as system.println error or whatever, right? Okay, next pop. Pop is remove. You remove, so you will remove the top elements. Always, remove the top elements. You cannot remove the element at the bottom. You have to follow the rules. In reality, if you have stack of books and you want to remove the book in the middle, or you want to remove the book at the bottom, what will happen to the stack? Can you imagine?
Berterabur.
Berterabur is like apa in English? Sven is here. He doesn't understand terabur. Collapse. Collapse ke ataupun
Messed up.
mess up. Yeah. Alright. Okay. So same goes for stack. Yeah. Stack here in stack implementation. You want to pop out, then you pop the top element. Yeah. So you want to pop this. Alright, so this one should be very easy. Memang very easy. Right, so you want to pop this one, you just remove the stack dot pointer to be pointing to here. Okay, so now this one is no longer in the stack. Okay, so the code is, yeah, I have the code already here. Stack top equal to stack top dot link. So this one is stack top dot link. Okay, I hope by now you understand already how to access the pointer. So this one is stack top, and this one is the one that point to the next node is called stack top dot link. Yeah, so this statement will do. Yeah, stack top equal to stack top dot link, and this is the final diagram down here. Okay, so C is no longer in the stack, right? Okay, just one line of statement, and of course you add in error checking also. Yeah, before you pop, make sure the stack is not empty. Okay. Okay, so that one is actually implementation. Implementation, and you are going to complete the implementation of my stack. Okay, during the lab session this week. Alright, and next, of course, same goes with stack. There are built-in class stack in the Java collection framework that you can use. Right, and the name of the class is stack. Yeah, and it is in the same package java.util. Yeah, same package with array list, okay, linked list, right? So it is in java.util. Okay, so I have screenshot some important or commonly used method, yeah, for class stack. Take a look, take a look at each method, in the class stack, in the built-in class stack. Okay, so first is the constructor, right? And then empty, yeah, for checking whether the stack is empty. Okay, this is interesting. Pick, yeah, object pick. Okay, so the name of the method is pick. Pick. Why pick? Pick is what? What does it mean by pick, and why not top? Yeah, for me, I think I would rather put a method name top. Yeah, this one is exactly like top. Yeah, top. When you pick, then you will see the top. Yeah, the top elements of the stack. Okay, and then pop. Okay, pop empty parameter, no parameter, and then push. Of course, you need one parameters. Yeah, to implement, you need one parameters for creating, for passing the new objects as a parameter. Okay, and then one more method is search, yeah, with one parameter, returns the relative position of the item specified by obj from top of the stack. If the item is not in the stack, it returns -1. Right? So these there are a lot more, right? That you can explore and have a look at the built-in class stack from the Java collection framework. Okay, so far so good. Before we move on to stack application, any questions?
Good. Great.
So far okay, Doctor.
Okay, right? Okay, so let us move on to the application, application of stack, where actually this stacks concept are used, right? In application, in application. Okay, right. Like for queue, we know already that queue can be used in queuing system, like in the bank system, hospital, movie theater, printer, and so on. Okay, and stack also have this so-called kind of application that can be applied, right? Okay, so here I listed down some application that make use of stacks. Okay, number one is invocation of nested function, yeah, or recursive function. Okay, you have learned nested function, all right, and this nested function will be called inside, right, inside another function, all right, and the way the function are called actually is using the stack concept, yeah, which is last in first out, yeah. So the last function to be called is the last in, yeah, in the for the invocation. Okay, another one is recursive function. Okay, recursive function, this one will be the next topic that you're going to learn. Okay, so I will hold on, okay, on this one, and recursive function also using stack concept. Okay, number two, conversion from infix to postfix notation. Okay, this one has to do with arithmetic notation, where actually the infix notation can be converted to postfix using the stack concept. Alright, so next one will be discussion on this one. Evaluation of postfix expression, okay, conversion and also evaluation of postfix expression. What is infix? What is postfix? Yeah, I will discuss in the next slide. Okay, stacks can also be used for checking balance parentheses, yeah, for open and close. All right, because in evaluating the expression, okay, the one in parentheses, okay, will be evaluated first, okay, and this one you can use the concept of stack push and pop, yeah, for evaluating expression with parentheses, and also checking matching parentheses, square bracket, yeah, bracket, braces, right? Okay, and lastly, evaluation of complex arithmetic problems. Complex arithmetic problems can also be solved using stack. Okay, so let us move on to the arithmetic application. Okay, and how we can evaluate this arithmetic expression using stack. Using stack. Okay. Right, so as you all know, and you have been using it, arithmetic operators in whatever expression you're dealing with. Okay, so these are the basic operators, and you should be familiar with, familiar with it. Okay, so there are four main symbols here for multiplication, division, addition, and also subtraction. All right. And compiler will evaluate the arithmetic expression based on precedent rules, based on precedent rules. All right. So any expression in parentheses will be evaluated first. Okay. And then next level is multiplication and division. Okay, multiplication and division. And lastly is addition and also subtraction. Okay, the precedent rules from lowest to highest. So I have the arrow here up. Right, so meaning that if let's say in expression you have multiplication or division, right, and then you have plus or minus here, so you will need to evaluate the one at the higher level first, okay, and then only proceed with this one. Okay, we'll do exercises here on this one. Okay, let us move on to the next slide. Okay, so there are three types of arithmetic notation. Yeah, there are three types of arithmetic notation. Okay, first one is called infix. Yeah, infix. Okay, this is the one that we are familiar with. Yeah, infix notation. Okay, why infix? in here actually is a short form for in between. Yeah, so we are referring to the operator. So this is operator. Okay, and we have X and Y. This is called operand. Yeah, operator and operand. So the operator is in between the two operands. So that's why we call it infix. Okay, so we have been using this notation, right, all this while. Okay, for example, let's say we have the expression A times B plus C divided by D. All right, so based on the precedent rules, okay, so which one will be evaluated first? Which one will be evaluated first?
Set the bracket.
The one inside the bracket. Okay, so this one will be evaluated first. Okay, so let's say I have 1, 2, 3, 1, 2, 3, this one, 4. 1, 2, 3, 4. Okay, so I have 2 plus 3 evaluated first. Okay, so the result will be 5, right? And then next,
Times A.
yes, times A. So I have multiplication and division. So this one is at the same level. So it will be evaluated left to right. Yeah, so left to right. So this one, A times 1 times 5. So you get 5. Okay, and finally 5 divided by 4. So you get the result here. Okay, right? So this is how compiler will evaluate. Okay, right. Okay, next type is called postfix, yeah, or also known as reverse Polish notation. Yeah, reverse Polish notation. Post, yeah, post mean after. Yeah, post is after. So the operator is after the two operands. Okay, we are not familiar with this one, right? But you need, okay, compiler will need you to transform infix to postfix notation first before you can evaluate using stack. Yeah, I'll show the example after this. Right, let us take a look at the postfix notation here. Okay, just now we have the infix. Okay, the infix we have A times B plus C divided by D. Okay, in postfix, yeah, in postfix we will transform, yeah, we will transform into infix into postfix. Yeah, we will put the operator in front, sorry, not in front, at the back, yeah, at the back of the two operands. Yeah, so doesn't matter how you want to do it, but for me I will evaluate the one in bracket first. Okay, so this one I will evaluate this to B, C, and then plus, yeah, to transform into postfix, yeah, postfix notation. All right, and then next we apply A times. Okay, the order of the operands you have to maintain. So A should be here, yeah, before B and C, but the operator has to be after. Yeah, so A, BC plus A, then only you put multiply. Okay, and lastly, after you have evaluated this one, so next is D, right? So put the operand first, D, and then only followed by the operator. So this is the postfix notation of the given infix. All right. Okay, and then next one, yeah, next one is prefix. Yeah, there are three. Yeah, in, post, okay, and pre. What about pre? If post is after, pre?
Before.
Before, definitely before. Same thing, but only now we put the operator before, before the two operands, right? And then A maintain the order, okay? Because I realize sometimes students tend to get confused. So A is put here, after C. That is not right, okay? The order of the operand has to maintain, okay? And then you put multiplication here, all right, before, and then lastly is D, and then you put the symbol here, right? So this is the prefix version of the previous notation. Alright, so we have infix, postfix, and prefix. This is a very common question asked in test or final. Okay, you are given one expression in any form, in any notation, and you need to convert to the other form. Right? Okay, so this is the prefix. Prefix notation. It is also known as Polish notation. Postfix tadi is reverse. Okay, and prefix is Polish notation. Right? So you can see that the operator is before the two operands. Alright? So far so good? Okay, let us take a look at more examples. Okay, take a look at table 6.2. And the equivalent postfix expression. Okay, I would like you to add in one more table here. The prefix. The prefix notation. Just to test your understanding. Okay, done? Done, class? Okay, for first one, what is the equivalent prefix notation? Anybody would like to try?
Plus A.
Plus AB.
Number one should be easy kan? Simple je. Plus AB. Okay, second one. So we have plus and multiplication. So which one should we evaluate dulu? Which one should be evaluated first?
Multiplication.
Multiplication. So we have
Star
Which one?
ABC.
star
ABC.
ABC. Okay, so we have BC, right? Star. Where is it? Is it the star is in front or at back? This is prefix kan?
Pan.
Front. Okay. What about A? Then we have A. A.
Bodoh. Payung Azhar, I think.
Kat sini payung.
Ya, Payung Azhar elok.
Akmal
Oh, plus.
So like this. plus A multiply BC. Is that right? Yes or no? Yes. Everybody agree? Okay, third one. Third one we have A times B, right? So, anybody?
Plus
Plus?
multiply ABC.
Oh, sorry. Plus
Multiply
multiply
ABC.
ABC. Okay. Next. So we have A plus B multiply C. So
Multiply then plus
multiply
plus ABC.
multiply plus ABC. Okay, thank you. The rest also check. In case if you have a different answer, you might share also your answer. Okay, next one. So we have AB minus the postfix CD plus. Okay, lastly is multiplication. Yeah, this one is the postfix. So we should have what? AB minus and then
Plus CD.
plus CD, the multiplication. Where should I put the multiplication?
Depan.
Depan and front. Okay. Right. Last one. Last one is almost the same. So we have AB plus. Okay. AB plus and then okay. And then what? AB plus we have C minus D divided by E. So which one should I choose?
Divide DE.
Divide DE. Okay. This one is after AB or what?
Yep.
Sini. Okay, divide DE. What about C?
Depan DE.
C kat sini.
Depan.
Depan ke belakang?
Tepi
Sini.
bahagi.
Okay,
okay.
C. And then divide minus. Minus. Where should I put minus?
Beside C.
Before C.
Before C. Sini ya.
Hmm.
Okay, so I rewrite plus AB minus C divide DE. Okay, and then we have F.
F plus.
Plus. Okay, we have multiplication also here. So which one should come first?
Plus is beside minus. Before minus.
Okay, plus is before minus. Okay, and multiplication?
Depan sekali.
Multiplication is here and then plus is here.
Yep.
Okay. Right, because okay. Are you sure plus is here?
Plus next to before multiply. In front.
Okay. When you have plus and multiplication, so which one should be evaluated first? Multiplication dulu kan? Okay. If you put it in the middle here, so plus is evaluated first, yeah, on this part. Okay, so tak sama, yeah, it's different. Okay, so it should be plus at the front.
Before multiply.
Okay, so plus multiply and then we have plus AB minus C divide DEF. Agree? Everybody agree?
Agree with that.
Right? So you have to be very careful. Right? You have to consider the precedent rules also. Precedent rules also. If not, then you will get a wrong notation. Right? So from here you can see that this one is performed on these two operand. Okay, this is also performed on these two operand. Okay, and then followed by minus C, because this one is in bracket, yeah. This one is in bracket, C minus D divided by E, so it has to be evaluated first. And lastly, only you, and then you multiply with this one and this whole thing, right? You multiply and finally you plus F, you plus F. Right, so you have to follow the precedent rules when you transform into other notation. All right. Okay, more examples that you can have a look. Edit. For example, like the last expression here, we have B plus C divided by D. All right. So the postfix notation, we have okay, CD has to be evaluated first. Okay, when you have to be very careful when you have plus and divide here. So this one should be evaluated first. So that's why you have this next to each other. Yeah, CD divide and then only you plus B, and finally you multiply by A. Okay, and then the prefix version also you have CD, this CD. So this one next to each other. All right, and then B plus, because you add B first, it is in bracket, and lastly A and multiplication. Okay, and as I said earlier, the order of the operand has to maintain. Yeah, here you have A and then B, C, D. Sometimes students tend to get confused. For example, you have C, D divide B, and then A here. You have plus multiplication. Yeah, this is wrong. Because A shouldn't be here. A should be before the operand B. So when I see something like this, definitely it's wrong. Okay, because the order of the operand is not right. Okay, so that is one way to double check. Right? Okay. So next part is evaluating postfix. Evaluating postfix expression using stack. Evaluating postfix notation using stack. Okay, stack. As you know that the data structure is last in first out. Last in first out. Okay, so this is situation. Okay, situation of simple expression. So you just want to add 6. The expression is, sorry. You want to evaluate 6 plus 3. 6 plus 3 using stack. Okay, so based on the algorithm, okay, when there is an operand, you will push. Push. So here we have 6, so push it on the stack. All right, okay, but here, before you can evaluate, you have to convert it to postfix. That is the rule. You must convert to postfix. So in this case, when you convert, so you get 6, 3 and plus. 6, 3 and plus. Okay, so next one is 3. So 3 is operand, so you push here. 6, 3. Okay, and then when you see operator, then you will pop. This one pop and evaluate. Okay, so pop these two out, pop, and then 6 plus 3. So you get 9, and then push it to the stack. So this is where you get 9. Okay, so that's how the postfix expression is evaluated using stack. Okay, more examples. So here we have Operator 1 times operator 2. Okay, operator 1 times operator 2. Operator 1 is, this is, I suppose, 9 times 2. So when you convert to postfix, it becomes 9 to multiply. Okay, so you push 9 first, first element push here, and then 2, and then when you reach the operator, you evaluate. Evaluate. So this one is 9 times 2, right? 18, you push back to the stack. So the answer is 18, right? Stack after popping the element. So the result you pop out. Yeah, the 18 you pop out, so you get the result equal to 18. Right, so just take note, okay, when there is operand, you push. Okay, when there is operator, you pop. Yeah, you pop and evaluate the two operands. Right? Okay, I have the algorithms on the next slide actually that you can refer to. Wow, it's raining heavily here. What about at your place?
Okay.
Belum lagi.
Okay, belum
Rain,
lagi.
rain.
Oh, Shah Alam is raining heavy rain. Buruh, kilat semua ada. Alright, so this is the algorithm. Okay, first evaluate expression using stack is only allowed for postfix expression. So please take note, this is very important. Okay, you need to evaluate, transform into postfix dulu. So let's say you are given a question in infix. Yeah, the question is in infix. So you need to convert to postfix first. If the question is in prefix, for example, you need to also convert to postfix first before you can apply this algorithm. If it is already in postfix, then you are lucky. Okay, you don't have to convert. Okay, so you just proceed with the evaluating the expression, okay, using the algorithm. Okay, so these are the steps. Okay, create an empty stack, number 1. Number 2, while not end of expression, get an item. If the item is an operand, push onto the stack. If the item is an operator, pop. Yeah, bila you reach operator, of course there will be 2 operand, pop operand 2 and pop operand 1. Yeah, 2 operand, evaluate the expression. Okay, push the result back onto the stack. Right? When the end of expression, the only item left on stack is the value of the expression, pop. Yeah, pop the result. Yeah, pop the result out. Okay, very common question asked. Okay, I think almost every semester there is question on this one. Yeah? Not only for test, for final also. Yeah? So what kind of question? Okay, let us take a look in the next slide. Okay. Okay, given the following postfix expression. Yeah, given the following postfix expression. So as I said, when you are given the expression in postfix, then you are lucky. You don't have to convert it, yeah, to any other notation. But if it is in infix, yeah, in infix, yeah, for example, you have what is the infix notation of this one? Okay, instead of characters, I have value here. What is the infix? Can you figure out the infix notation for this one? What is the infix notation? This is what? 4 minus 2.
2
And then
plus
plus
1 times 5.
1 times 5. Right? So when you convert, you get, okay, 4, 2 minus 1, 5 multiply and then plus. Okay? Right? Okay. So let's say you are given the question in infix like this. Right? In infix. So you need to convert to postfix. Yeah? Convert to postfix. So this is the postfix notation. Okay, how do I draw, okay, the work? Okay, because normally question like this will ask you to show the steps of evaluating the expression using stack. So what you can do, you can just draw like a table in this form, right? So I draw it again for you, right? So this is like you know, table with columns, depending on 1 2 3 4 5 6 7 8 1 3 4 5 6 8. Okay, so the one on the bottom here, you write down the postfix. Yeah, after we have convert to postfix, then you just put it in each column. So 4 2 minus 1 5 multiplication and then plus. Okay, so the one here is like a group of stacks. I put it together. So first you will look into the first item 4. Is it operator or operand? Is it operator or operand?
Operator.
Operator?
Operand.
Don't get confused, Akmal. Yeah, operand is numbers ataupun value. Value or can be characters. Okay, but operator is plus, minus, and so on. So based on the algorithm just now, if it is an operand, push. So I push 4. Okay, next 2. It is another operand, so I push 2. Okay, when you push in, when you go to the next step here, make sure you rewrite 4. Push 2. Right, sometimes student misplace. Okay, misplace, or you know, instead of putting 4, then just put 2. Okay, you will get wrong result then. Okay, next, this is an operator, minus. Yeah, for, oh sorry, so this one sepatutnya saya letak sini 4, and then sini 4 2. Okay, first one is 4, second stack 4 2. So when I encounter this one, minus, so I'll pop out, this is operator 2, this is operator 1. Okay, so this is 4 minus 2. Okay, not 2 minus 4. Yeah, operand 1 minus operand 2. Yeah, 4 minus 2, you get 2. Push back to the stack. So now I have 2 here. Okay, continue on. Okay, next one is 1. 1 is an operand. So 2, rewrite 2, 1. Okay, and then 5 is another operand. Rewrite 2, 1, 5. Okay, next is operator. So you will pop out the last 2 operand. Pop out this one. Okay, pop this one. So this is 1 times 5. So push back the result, 5. Am I right? 2, okay. Yeah, push in the result 5, but don't forget we only pop out 2 last operand, so we still have 2 here, right? Maintain, and then 5. Right? And lastly, plus, we pop out 5, 2 plus 5. So we get 7. So push back here 7. And finally, pop out the result. So result equal to 7. The last one. Okay, so far so good, class?
Yes.
Alright, so understand how I come out with the working here? The steps? Any question?
No,
For
no.
the
Alright, so far so good, Okay. Let me see first. Okay. Next slide, which is the last slide. Okay, I have one more slide, right? Okay, this is another way to convert from infig to postfix. From infig to postfix. Okay, one way is I would say the faster way, but you need to understand that. Yeah, you need to understand in terms of the precedent rules and so on. You can straight away transform. Okay, but if you are to show the work, okay, if you use the first way, okay, you show me the work something like, okay, which one you evaluated first. For example, here you have this one you want to transform to postfix, right? Okay, you can just show me. Don't just give me one final answer, yeah, without showing the steps. Okay, so here you can show in terms of for example here, right? So first you evaluate this one, yeah, C D divide. Okay, and then next one, yeah, next step you have B C D divide minus. Okay, and then next step, which one do you add? So you have multiplication, right? So multiplication, you have B C D divide minus E multiply, and last answer will be A B C D divide minus E multiply plus. Okay, don't just give me answer like this. Okay, so you might lose some points, yeah. Okay, because not showing the steps, right? Okay, I don't know how you get this one, right? Okay, but at least you show me the work, okay, how you get this result. Or yeah, this is one way. The second way is you can draw this table. This one is a bit lengthy. It is a bit yeah, as I said, lengthy. Okay, step by step. Okay, what you can do first, you will put the infix expression here, yeah, on the first column. Okay, one row for each operator and operand. Okay, and then second column is the stack. Okay, next column is the postfix expression. Okay, so you will check one by one. Yeah, if it is an operand, then you push it to the postfix stack. Yeah, postfix. If it is an operator, you push it on the stack. Okay, okay, so this is next operator, you push it on the stack, right? And then you encounter operand. You push to the postfix. So you have A B here. All right, so this one, it will check the matching parenthesis. Yeah, matching parenthesis. So you will keep pushing the operator to the stack until you reach the matching parenthesis. Yeah, after you have which one here? A B C D, right? Divide. Okay, and then after divide is the matching parenthesis, right? Bracket. Yeah, right bracket. So you can start popping out. Yeah, popping out the operator on top. Yeah, so the one that you pop up is the division. So you put here in the postfix. Okay, and so on. Yeah, and so on. Okay, until you have completed the scanning of the operator and operand. So this is your final result. Okay, yeah, I know some students prefer to do this way. It's okay, or maybe you can just I would say the shorter way. Okay, but please show me some steps, yeah, before you can get the answers. Yeah, right, this. All right, but somehow if you use this one, you have also need to check the precedent rules. Yeah, you need to check the precedent rules. Yeah. All right. Okay, so that's the end of stack. Okay, so for stack, two parts. Yeah, two parts. First one is the concept. Actually, three parts. Yeah, first part is the concept. Okay, second part is the implementation. Okay, and the third part is the application. Yeah, application using stacks. Yeah, and we focus more on the application of arithmetic expression. Okay, any questions so far?
So far, okay, doctor, no question.
Okay, all right, good.